This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Well, hello, I'm Lee Bortons. It's Wednesday, March 5th, 2025. Welcome to the Math Map Book Club, where Kirsty Gilpin and I discuss lessons each week from our math curriculum for families with students enrolled in classical conversations communities. This academic year, our club's working on a lesson each week together as we prepare to answer our children's questions. And as we near the end of this academic year, I encourage you to finish strong. So Kirsty, we are moving into the last few weeks. What do you have for us?
So we are this afternoon, looking at lesson 26. It is accumulated change. And I think I like one of the things that you just said about finishing strong, and that idea of accumulated change is encouraging to us that, right, sometimes we're tempted to judge ourselves and our progress week to week, right? Or right, if you weigh yourself every day and you see that scale go up and down, right, and it goes up and you're discouraged. But what matters is that long-term accumulation, right? What are we doing over the long period of time? And so as we finish well, having that broad view, right, we're reminded by this lesson of accumulated change, that how is all of the things that we've learned work together to get us to where we are at the end of the year. So just a random thought as we start. So of course, every week we start with our math map, and we start by talking about where we are. And we are here. We are in our fourth and final lesson of 4D, talking about accumulated change. And if you haven't been with us for a while, you might be wondering, when we look at the lessons, we're going to be mostly looking at two variables. And that question might be, so if we only have two variables, how are we in 4D? And so just to remind us all that when we talk about 4 dimensions, it's hard, right? 4 variables is a lot to keep track of. The calculation becomes challenging. And so one of the things that we decided to do was, as we understand time, helps us to understand sort of this idea of motion and movement. And I think, Pam, if you could mute, thank you. As we think about motion, right, it's always how are we moving in time, and how are things changing in time, that this idea of time is important. So we took all of these lessons that either had to do with time or rates or movement, and we put them together in our 4D lessons here, because they're pointing us to this idea of these patterns again that can transcend just one dimension. And then, of course, this year we are working through using the complex lessons. So if you have the complex booklets, that's great. You'll see in front of you what we have on the screen. But if you are working through digits, naturals, or fractions, those lessons are just as good. And so one of the things that Lee really wanted to create with the math map, remember, was a curriculum where we could have students that were working at the pace, right, or working with the numbers that they needed to work on, but interacting with these big ideas, right? And so historically, your calculation skills were a gatekeeper to talking about big ideas of math, and even to interacting with the language of math. And so one of the things that we've done is said that both of those things matter, but they might actually be accessed sort of separately, if that makes any sense. So we can be working on one level on our computation, and another level on our understanding of the language of mathematics and the ideas of mathematics. And so that's why the domains are there, to let you interact with math at the computation level that you are ready for, while still interacting with the same big ideas as everybody else. So again, we're still working through quick flip arithmetic, and you might feel like I am milking this game for all it's worth, but I really want to help you understand, right, that these cards give you a limitless number of games that you can play, right? Or not necessarily games, but a limitless number of exercises to practice with. The last week we talked about stepping into the algebraic realm. And this week I'm going to take that and extend it just a little bit farther to look at the distributive property, but now using 4 cards. And I'm going to arrange those 4 cards in such a way that I'm using the form A times bx squared plus cx plus d. Right. And so my cards are A, B, C, and D. So as I flip over my cards and I see this week I included a jack and a queen. So I'm seeing that I could use bigger numbers than just 0 through 9 or 1 through 9. And so I would write this and then read it. And again, I really encourage you with your students to read what you write, because I think that's going to be helpful in developing that fluency with the notation. But also, I was having a conversation earlier, how important that conversation is to assessing understanding. We were talking about AI, and one of the things that AI can't do for your student is have a conversation, right? So your student can go and plug in an equation and AI can spit back an answer and can maybe even give them the steps to the answer. But that AI can't sit down with you as a parent and read it aloud or explain how the student did the work. And so that communication between you and your student is going to be really important to helping them to work through their own understanding. So as we read this expression, we have negative 11 times the quantity, 3x squared minus 12x plus 1. Then as we calculate, some students may be able to jump straight in, but I did demonstrate here how with, let me find my mouse, turn on my pen, right? How I took and I changed this minus to a plus a minus. And that may help a student not to lose track of those negative signs, right? So here I have negative 11 times 3x squared, negative 11 times negative 12x, and negative 11 times 1. And I really always encourage students to draw those arrows to show the physical distribution of one term over the sum. And then as we calculate that, we see that we end up with negative 33x plus 132x minus 11. Any questions?
Not a question, but I like how you wrote that out because I feel like I trip up on those signs sometimes. And so I think seeing it written out, expanded like that, and the arrows with a different color. So I think that might be helpful for us if we're trying to do it in class, like writing it on the board as they're talking it through and then that kind of thing. Because I think that just, I'm a visual learner, so I need to see it out like that. So I like the way it's displayed.
So some of you probably have heard me get on my soapbox that all of multiplication is distributive. The distributive property might be, I think, one of the most important properties of mathematics because all of our multiplication after we finish our facts of 0 through 9 depend on the distributive property. And so helping our students to see what we're doing is really important. Now, Babs, I love the fact that you said, right, helping them to see that. You could also practice taking this distributive property and writing it in a different form, right? So you may want to practice writing this as 3x squared plus negative 12x plus 1 times negative 11. And notice even if I write this vertically, I'm still distributing because first I multiply here, then I multiply here, and then I multiply out here. Right. So I'm still distributing, even if I'm writing this vertically. So especially with your older students, I would encourage you to challenge them to look at writing this in different forms so that they can see it doesn't matter how this is arranged, that it's all the distributive property.
I like how you did that because what it made me think of is I could just take 3 cards and have the child tell me the trinomial that's there. And then just say, all right, let's flip cards. Okay, what is it times 2? What is it times 7? What is it times 8? Like you can just take the one equation and do it many, many times.
That's a great idea, Lee, and what a great way to speed it up a little bit.
Mhm.
All right, well, here's our, as we look at our cover this week, I'm going to start our timer. What do you see in our art? And how many of you would agree that this is art?
I see lines.
Good. What kind of lines? How would you describe those lines?
They look circular.
Okay.
What I know is it makes me know there's an artist somewhere.
I think I say this every year, but I always think these are wood. These are made of wood. They look like wood to me, not rock, like not like a mountain. But I know that they are, I know just because what we've talked about, but it looks like wood. So to me, it looks like a creation, like that it wasn't like a creator, like somebody actually built this with wood sticks. And so it does kind of make us think about that if this is really rock and it was made by the creator, that it had, we talked about this yesterday. What week were we on? 23, about a creator. Like, how could you think all these, oh, we were talking about the human body, about how intricate everything was. How could you not believe in a creator? And so looking at this, it's so detailed. How could you think that was just formed by not a creator?
And foundations, we were talking about Dürer in our arts, hands-on art yesterday. And we were doing the wood block printing and just engraving it on styrofoam. Then this looks like somebody, a creator, have taken his tools and engraved it over time.
What's amazing to me is just the amazing geological processes that God could do, even with something drastic like the flood in a short period of time. You know, you can carve Mount St. Helens in the canyon. It's like, what was it, 1/8 of the size of the Grand Canyon in a day or two. And sometimes what we think would take so long, actually, God can do with catastrophes or with just his natural creative power in just a moment. And it kind of speaks to what he's able to do in our life too, what can seem impossible for us to accomplish. Boy, he can do mighty and amazing things for us fast.
Yeah, so Yating and Tanya, one of the things that you guys just made me think about is that if I was to create, right, I might think I need to use paint, right, or a paintbrush or a carving knife, that those would be my tools. And yet God actually uses the earth itself, right? As it like he's moving, when we think about mountains like being created, like he's actually moving the earth and the plates of the earth, right? What does that mean, right? About his power to create using, I mean, huge, great big things, right? Um, Unexpected things. And then that, Tanya, kind of, speaks to what you were saying, right? That these elements of my life, which might seem huge to me, that God can use those to create beauty.
Makes me think about when you watch like a time-lapse video of like flowers or plants and how they move. And even if we could see a time-lapse video of when some of these rock formations were formed, it would be, I mean, and God sees that, it's all worshiping him, right? Creation. So it's really neat to think about.
also love that there's a little bit of green in there, where we see non-living rock matter, those atoms put together. We also see the atoms of life put together, though it's different from, human life and animal life. It's still life, and it's so beautiful to see how one can thrive upon the other. It's
In previous years, the students talked about other things that look like they are not moving at all, but really are. Like how they grow, or how bread rises, or how anything that it takes time for that thing to change. But looking back, you can see how it grew. So it was always I'm looking forward to this conversation again this year.
Jill, I love that idea, right? That in the instant, we don't see the change. But when we look beyond the instant, we are able to see the change. And Tanya, that you're pulling out that piece of green reminds me recently I was able to be with Babs and Michelle Oliver, another CC lady, and we happened to be I think it was at one time a quarry, and so it was dug out of limestone, so it was all rock, and there was a tree growing out of it. And that idea, right, of this life growing where it appears no life is possible. And it made me think that sometimes it's really easy to judge a person or a situation and think it's barren, that there's no life that can come out of it. But God can bring life, right, out of anything. I mean, right, he called the dry bones, but God can call life. And so there's nobody in my life that I should write off, because God can pull life out of anyone. And so I was encouraged by that.
That's so beautiful. That reminds me, when I was before I was saved, I actually had somebody write me off. And like, they told me about this after, because they saw me at church one day and were like, "Oh, what is she doing here?" Like, I had that great of a reputation. Anyway, full disclosure. And he after said, "Wow, I can't believe I thought that, because God can do anything with anybody." And it's such a testimony to his great power, isn't it? That's so cool.
Amen. So thinking about our 12-year-old or 13-year-old students as we look at this. So I think it was Yating's student that said that they saw some curved lines, right? So they were looking at the curve. What other kind of lines can we see in this picture?
I see parallel lines. Same.
Yeah, there's a lot of parallel lines. And that might be important. So we're going to be talking about calculus, and we're going to be talking about integral calculus. And one of the things that over time, especially, students are going to be introduced to is this idea of taking our intervals and slicing it up into ever narrower rectangles, right? And so here's a question you could ask your students. If we could find the area or the volume of each of those columns, right? So think about a column, right? If you took at home, right? If you asked your student, well, here's a column, right? As a tissue box, but do you know how to calculate the volume of this? Right? They might say, yeah, I can calculate the volume of that. I can do its length times its width times its height and get its volume. That's something that's accessible to me because we've learned that this year. And so that feels accessible. But if I was to give them a really confusing shape, I'm looking for something that I have, right? Maybe a teapot, for example, right? If I said to them, find the volume of this teapot, that would be a lot more challenging, right? If I said, find the volume of this mountain, I don't know. Anybody know how you would find the volume? But if I said, can I find the volume of each of those rectangular prisms? Yeah, I could do that, right? Well, if I add all of those rectangular prisms together, would that be the same as the volume of the mountain? Right. So that's the idea that we're going for when we talk about integral calculus, is that, right, I can take these shapes that are familiar to me, that I can calculate, and I can add them all up in order to find something bigger that may be less familiar or maybe daunting to me to do that. Right. And so it's a great reminder, right? Just like we talked about at the beginning, this idea of accumulated change, right? That um, we can add up all of these little things, right? So defining in a big sense, how did you grow this year, right? When we get to reflection, we're going to be like, well, how did you grow this year? That might be a really big question, right? But if we can start to identify some of the small ways we grew and add those together, we start to get a picture, right, of overall growth. Anything else anybody wants to comment on our art today or our
I want to add that I love the quote, the prayer by Charles Spurgeon, because we're learning calculus not because it's a STEM subject or we'll make more money, but calculus will actually help us serve God better.
what a great reminder.
Also, there's still a blue sky when you're doing hard math. We could still look up and see blue sky.
All right, so if you were with us last week, this page may look familiar to you. And because it is challenging to look and think area, what we're going to do is we're going to use, we're not necessarily going to talk about integral calculus as area when we look at this chart. Instead, we're going to look at this chart and think about integral calculus as an antiderivative. In other words, we're going to say that the red function, right, is the function for which the black function would be the derivative. Okay. Now, if you remember last week, what we did was we compared our black function and our red function, and we said, what's the slope of the black function and what's the value of the red function, right? And so we would look and we would say, okay, well, the value of the slope of the black function is positive and the value of my red function is also positive. And so we saw that. Well, this week we're going to switch our colors, but we're going to have the same conversation. So this week, instead of looking at the black function, we're going to look at our red function and talk about the slope of the red function and compare that to the value of the black function. Okay, so if we look at our top left where it says our constant, right, so up here, our constant function, what is the, again, we're going to look at the red. So look at this red function here. And what is the slope of that red function?
1.
1. And so now look at the black function. What is the value of that black function?
Equals 1.
Slope would be 0.
The slope would be 0, but the value
the
of the function
value.
is y equals
Y
1.
equals
Does that
1.
match our slope of the red?
Yeah.
Yeah. Right. So now let's look here at where it says linear, right? So we're going to start with our red and we're going to look here at our red. What is the slope from negative infinity to 0? What kind of a slope do I have?
Negative.
Negative. And so now let's look at our black function and what kind of values does our black function have from negative infinity to 0?
Y equals negative.
Negative. And my slope from 0 to positive infinity is
Positive.
positive, and my value of my black graph from 0 to positive infinity is
Also positive.
also positive, right? And so we could keep going. So let's look at this next one here. So our red graph, what is my slope? My entire function, my entire red function, what would be the slope?
Positive.
Positive. What would be the value of my black graph?
Also positive.
Also positive. Now here's a question for you. I'm gonna try and draw this. We'll see how well I do. So I'm gonna pick a different color. let's say that I looked at this line, the blue line. What is the slope of that blue line?
Positive.
It's
So one.
still
one.
one. And
Oh.
so is the slope of that blue line the same as the value of my black line, my black graph?
Yeah.
Yep. So
Yeah.
let's look here. Okay. So now I'm looking, it's supposed to have the same shape, just be translated down. Okay. So now looking at my blue, does my black line still match the slope?
Yes.
I want to make sure I'm
Everybody agree?
following you. The blue values are now negatives.
So the blue values are negative, but how about the slope of the blue graph? Does that
Like it's the
slope?
same shape. So
So
the
is my,
slope
And it's
would be
still
the same,
going,
but different
still
values.
going positive.
yep. So I'm still have a negative slope here, right? So this part
Mhm.
here is still negative, and that matches, right?
Because the values are negative, not the slope. That's why you're distinguishing between the slope and if I plugged XY and got a point.
Right. We're just interested in the slope because we're talking about is that black line being the derivative, right? And so what you'll see where I'm going in a minute, right? So here, positive slope, positive values. Let's take a look here, right? Does my slope change even though I've moved that graph up and down? So
No.
It's still
no,
positive.
still positive, right? So we could keep going, right? Could I probably make an infinite number of graphs that have the same slope?
Yes.
Yeah, right. So notice I could keep drawing lines and they all have the same slope. I could keep drawing parabolas and they all have the same slope. I could keep drawing my quadratics and they all have the same slope. So they all have, right? So if I have the same function just translated up and down my y-axis, okay, they all have the same derivative.
Is that also true if you travel along the x-axis?
No, because now let's take a look at this one, right? If I was to move this here, right? Now I've got my derivative is also going to shift this way, right? Because it's going to be negative from this point here and positive from this point here. So it's if I translate left and right, my derivative is going to translate with me. But up and down, my slope is the same.
So when you said that if you shift it on the x-axis, that it changes, what is the it that changes? Is it the slope or the values or both?
So my slope, let me think how I can say it. So if let's draw this bigger. It's where the slope, right? So if I look at these two lines, right? Well, maybe lines aren't a good choice because they don't ever change, right? But at both of these points, my slope is the same at the relative place, right? But if I was to graph that, it would be different. So let me do it on this side with a different shape, and then I think you'll see. So if I had a parabola here and a parabola here, and I look at the same relative point, right? Well, if I was to look here, this point here and this point here is where my slope is 0. So that's where my derivative is 0 for each of these. On this side, it's negative. On this side, it's positive. And here, right? It's negative on this side, positive on this side. At this point here, whatever this value is going to be the same. It's going to have the same y value, but notice that my graph of my derivative has been translated along with the graph of my function. Does that answer your question?
I think so. Thank you.
It doesn't answer my question.
Okay, what's your question?
I have the same one that Jill does, and I just want to confirm it. So the shape of that slope curve that looks like a cubic function just moves right and left. So therefore your x value changes, but your y value doesn't. Is that all you're saying?
Yes.
Mhm.
Yes.
Okay. But whenever you moved up and down and not right and left, nothing changed.
Nothing changed. Exactly.
Can you say that again
So-
one more time?
That's
Sorry.
tricky.
Yeah, say that again.
So if I translate left and right, that my slope, if I translate my function left and right, my slope graph is also going to translate left and right? So there's going to be a change to my x value. But the value of the slope, the corresponding value of the slope, essentially the y value, isn't going to change. But if I'm translating up and down, nothing changes.
I feel like there's a spiritual truth here happening about our relationship with people on the horizontal. It's always all over the place. And the up and down, it's solid.
Oh, that's so good.
You know, and I would have to go and get a piece of paper and prove to myself what we just said. I can describe it. It doesn't mean I believe it or understand it well enough to teach it to someone else, right? So that's where you're going from dialectic to rhetorical. And it just helps us as parents to see when our children are struggling. They can do the problem, but they don't know why they can do the problem. And so that's where I am too.
Yeah. So we've gone and we've asked some questions and we've started to explore this in a great way. So I'm just going to pull us all back, and all I want you to see, as we move on from this page, there's two things that I'd like you to see. One, that the black graph gives you the slope of the red graph. Okay. And so that is the picture of the antiderivative, is that the antiderivative is the function, for which our given function is the slope. Okay. The other thing I'd like you to see is that we may not know exactly which function that is, because there's an infinite number of functions that have the same slope. And so when you get into the lessons, you're going to see, when we take the integral, you're going to see there's this thing where we have to put a plus c on everything. And that plus c just says, hey, if the integral of x is x squared, and let me erase. No. Erase this. There we go. So the integral of x, so here's y equals x. If I integrate x, I get y equals x squared, right? But it could be x squared plus 0. It could be x squared plus 1. It could be x squared minus 1. It could be x squared minus 4, right? And so we write plus c to account for all of those. Now, for those of you who had a lot of fun last week with derivatives, if you went home and you were playing with calculating derivatives and looked at the lessons, if I was to find the derivative with respect to x of any constant, that's the same thing as saying c times the 0th power of x. When I find the derivative, remember, I multiply by 0. And so what's my derivative of any constant? 0, right? And so that c, right, and when I take the derivative, that c just goes away. But when I integrate, I have to account for the fact that that c may have just gone away. And that's what we're doing here. So I just wanted to show you that graphically because we can do it algebraically and we can say all of those things. But I think playing with the slope and saying, oh yeah, the slope is positive and negative and it's still positive and negative, right? That slope relationship doesn't change no matter where I am vertically, helps us to start kind of getting a sense of what we're talking about. All right, looking at our Memoria and arrangement page, right? What are some things that may be familiar to your students on this page?
Well, we saw the names and the graphs last week in the charts and in the iPages.
So
Yeah, is
familiar with the names of the paragraph.
good. So have we been looking at this list of functions for quite some time? Yeah, so we really want to encourage our students. Hey, look, you're seeing this list again, right? We've seen this on iPages. We've seen this in the lessons. We've seen this on the charts. We've seen this lesson over and over and over again. Have we seen the graphs of the parent functions? Yes, we've seen those graphs over and over again, right?
Is this going to
And
be on the flashcards for logarithm?
it won't be on the logarithm flashcards, but we are planning a deck that will have this, but it may not, it's going to be, right, it's in development. So it's coming, not there yet. But that doesn't mean that you can't make your own flashcards, right? So there's a great example of a mom going, hey, we keep seeing this. This would be great stuff to make some flashcards, right? And so encourage your students to do that.
Yeah, that's what I was thinking about. That would be a great flashcard set. How many flashcards are we having in the pipeline? Just out of curiosity, because we can make flashcard set after flashcard sets.
So we right now we have trigonometry that we're working on. We have algebra that we're working on. And then after those two, geometry and relations. So we're working, eventually we have 10 that we've identified that it's our goal to have out. So, so again, right, so here we've seen this. Now let's look at these 3 columns here. What does this arrangement maybe tell you about the relationship between the derivative and the integral and the function itself?
Well, I'm going to tell you because I see it. So if you go to x minus h, you get a 0. And to the left, you get a lesser number. And to the right, you get a greater number for the index.
Good.
If you were looking at these charts with even younger children, like maybe fractions level, it might remind them of how whenever they play number knockout, if they use power of 0, they can always add 1 and subtract 1 to every number. So every single number they find, they can also do the one right below it and right above it. And there's something, and there's something on either side of it.
Good. So last week we talked about the derivative. If we look at our function, right, and we found our derivative, that would be to the left. And then moving up to the right, we're integrating, which means that this middle one right here is actually the integral of the derivative, and it's the derivative of the integral, right? So you've got like bonus examples here of derivatives and integrals. Right. So as we move to the right, we're integrating. As we move to the left, we're differentiating. And one of the interesting things is that as we move to the right, as we integrate, we're actually looking at increasing our dimensional understanding of something. And as we look, or the number of dimensions, And as we moved to the left and we differentiate, we're actually decreasing our dimensions. So I'm not going to delve into that, but just thought I'd throw that out there. All right. So apparently
I think something that might help, I don't know. Is, parents are very concerned about their children doing well in math, and then they look at this curriculum and ask kind of two questions. Is it enough or is it too much? It tends to be right the extremes of their concerns. And I think what would happen is a parent would look at this chart and who's had a regular traditional math background and just say, this is just too much information. But where's the problems for my child to do? And not recognize that if they would just slow down and learn the 16 functions, their child probably doesn't need to even do a whole bunch more problems because they'll see the patterns so much quickly that they'll be able to plug and chug all they want if they end up having a career in math. So anyway, I'm just throwing that out there because it is overwhelming. I'm not saying it's not, but this one page is less overwhelming than an entire calculus book. Right? So anyway.
I remember one of you said that the whole point of practice is to discover the patterns anyway. And so if we practice looking at patterns, then the practice takes care of itself, which I thought really was amazing.
Well, and I feel that that page, you could sit here and just contemplate even 2 of the lines, and that could be your math lesson for the entire day because there's so much rich content in just one of the lines, but just taking constant and align, which most students at this level would probably be familiar with, and look at the relationships and the patterns between just those 2. Very cool.
So one of the things I really wanted to take a minute and point out to you, so I have put the charts from last week and this week together on the screen. Right? And you may want to do this with your students and ask them to compare. Right? So can anybody, or would anybody like to compare these 2 pages?
I need stronger reading glasses.
Well, don't even look at the detail. Look broadly with your fuzzy eyes. Do they look similar?
Yes, they're laid out very similarly.
Mm-hmm. And even the image on the top left corner is similar.
Yeah, there's like some big type, then there's some lines, there's an image, then there's this section in the middle, and then there's these columns and rows underneath. And gosh, what do we see there again? That same list of functions, right? And so lesson 25 and lesson 26 were intentionally designed to be very similar in their layout to help students to see the inverse nature between the derivative and the integral. Okay. So there's a lot on the page, but it is, and I want to say this, right? Not just grammar, because grammar can be really hard. Grammar can be very detailed. Grammar can take a lot of work to learn, right? But it is grammar. And that as we are memorizing the grammar, as we're attending to this grammar, that's where we're going to start to have those light bulb moments and go, oh, wait a minute. Like, look, these things go together. And that's where we're going to start to understand. And so for those of you who were just saying, hey, taking time to contemplate, this is maybe one of the best examples of taking 2 weeks worth of charts and laying them next to each other to see and compare and look for patterns between the 2.
I'd like to point out the 25 in the middle, it's always dy divided by dx. You're always dividing. And on the right, it's y times dx. You're always multiplying. And I'm familiar with division and multiplication. I'm just not familiar with this notation.
And I was going to say, I love that this week, the word used there is integration. That's awesome, because that's what we're doing in all the places. Like, we're learning the particulars and integrating them into this. Oh, I've got chills.
So the same is true on page 2 of the charts. And if you look, we have rules for derivatives and rules for integrals. And we're going to talk about sum and scalar rules for derivatives on the one, for integrals on the other. And then I'm going to just point out that here, this part right here matches to this part right here. So it's not as perfect. So we're going to see that for derivatives, we actually have a separate product and quotient rule. And for their inverse is just one rule, which is integration by parts. Then we have here the chain rule, and that goes with integration by substitution. But you'll see here it references the chain rule. This talks about a composition of functions, right? These are functions that are being multiplied and divided. So we're taking, again, all of these functions on page 1 of each of the charts. We looked at, here are your key functions and their derivatives. Memorize this. And then on page 2, we're going to say, okay, well, look, if you're multiplying them, right? If you're adding them, scaling them, subtracting them, multiplying two functions together, dividing a function by another, or composing a function with something else, right? Here's how you handle that when it comes to calculus. Can anybody think of any other function? Now, and understand when I say this, right? I'm thinking algebraically, not necessarily getting into other realms of mathematical study where we may have specific functions that we are going to define. But when we think about the functions that we're looking at, right? If you take our basic functions that we've talked about, right? I can add them, subtract them, scale them, multiply them, divide them, or compose them, right? And all of our other functions are going to be some form, the ones that we already know. Right. So as Jana said, learning the particulars, when we're learning all of these functions, so as you notice, we keep looking at these functions. Let's learn these functions really, really well, because then what if I put them together and I do weird things? Well, if I know what the building blocks are, right, it's going to help me to understand their composition or their product or their quotient. And so that's what these rules are about on this page. So it's pointing us to more than just calculus, right? But this idea that there's this whole wealth of functions out there, but we've already, right? We already have a fundamental understanding of them if we're studying these key functions. Any questions?
I know I haven't been here for a while, but so can I just use an analogy and ask if this is kind of like what you're getting at? It's a super simple analogy. So like the functions are like ingredients. Let's say you would find in your kitchen and you kind of know, okay, I know that I have flour or eggs or sugar. And if I add these together, I know kind of I will get a cookie out of this. Or if I just use yeast and flour and salt and water, I'll get pizza dough or whatever. Is that kind of what you're saying? Like, if you know the functions, you kind of can play with them and you kind of know what you're going to get at the end.
Yeah, I think that's a great analogy, right? But if you don't understand if you don't know the difference between sugar and flour, right? But by understanding, right, if I know my different spices, right? Right? Like, I don't know, cumin on its own might be great, but when I mix it with ginger, it does this, right? So that's a good analogy. So I'm going to kind of push off our questions or testimonies about week 25 because I'm going to look at the lesson pages from 25 and 26 together, and then we'll come back around and give you time for your questions. So here in the corner, I have put what we did last week in lesson 25, and I just want to compare it, right? So notice we're tracing our graph. We're tracing our graph. The next thing we did, we talked about whether or not it was in a differentiable. This week we're not, right? Because we're not talking about differentiation. Instead, we're going to integrate our function. So we're going to trace the integral. And notice here, we're being very specific. We're looking at where c equals 0. But then because we're practicing our functions, let's go ahead and practice the derivative. So here's its derivative. Let's practice whether or not it has an inverse. And then let's practice what it would look like if I translated it. Right. So notice that this week, 4 of the 5 boxes are the same that they did last week. Mhm. And it's tempting to think, well, gosh, that's boring. I did the same thing last week, right? But how do we learn, right? How do we accumulate grammar? How do we start to see patterns? Through repetition, right? That we start to repeat, we start to repeat, we start to repeat. So I am trying. While my son is gone, I told him I was going to commit to planking every day. It is not something I enjoy, right? It is not something he enjoys, but I was like, this is a hard thing for me, and I'm going to work up, and I'm going to like see if I could pass the Marine Corps fitness test for planking. And then so I started, and then I was like, what could I do to distract myself that's short? Well, I love Psalm 19, and I would really like to memorize Psalm 19. So I have combined the two things, right? So now, while I'm planking, I am reading Psalm 19 out loud because he's going to be gone for 89 days. So if for 89 days I repeat Psalm 19 at least once a day, I'm going to be well on my way to memorizing it, right? And I'm not going to get bored, right? It's God's word, and it's like one of the most beautiful chapters in the Bible. And so by doing that every single day, right? One, I'm going to be like praising God. I'm going to distract myself from the pain of a plank, and God willing, I'm going to be on my road to memorizing this chunk of scripture, right? And so there's a beauty in that repetition, right, of daily doing something. And so that's the same thing we're doing here is we're repeating this because we're saying, hey, this is what matters, right? Those flashcards that you were just talking about, right? Here they are in these lesson pages, right? Trace the function, look at its integral, look at its derivative, look at its inverse, look at its translation, right? Know what these things do, right? Day after day, week after week. And so when your students are tempted to complain, like, I've done this before, say, that's right. That's right. That's great that you noticed that. So now what patterns are you starting to see, right? What benefits are you getting? And so we see that here with our constant function, y equals 1. And we're going to see it here with our linear function, right? Here's its integral, its derivative, its inverse, and its translation, and then so on throughout the week. Then it's getting close to the end of the year, so it's tempting to think we know, right? But just like everything else, right? Repetition is helpful. So continue. Just want to encourage all of us to continue to encourage our students of what their resources are, right? The solutions for working backwards, the inside back cover for those questions that can extend the conversation, the back cover for playing games, the careful calculations for review, the flashcards for helping us to learn our grammar so we can read math, the companion so our parents have a resource, and our lesson pages to practice. And then before I open it up to questions, I just wanted to point out here in our upcoming 4 weeks, it's all we have left of this round of the Math Map Book Club. We're going to talk about complex numbers and proofs. And then in lesson 29, we're going to be talking about seeing the unseen. And I know that a lot of you have some examples. So I really would like you to bring an example It can be a picture you want to share. It can just be words you want to use, but bring an example of how you have seen either math in the world around you, how that math has maybe helped you to see truth, beauty, and goodness, and then how seeing truth, beauty, and goodness reveals characteristics of God, right? So there's this sort of hierarchy we're moving up, and you can be anywhere on that spectrum, but please bring how you've seen something new this year through your study of math. And then in April, when we talk about lesson 30, it is our reflection lesson. And I thought this would be a great opportunity for you to bring a testimony. So we're asking everybody to think about a testimony that you have from this year's book club, this year's walk through the math map. What is something where God has revealed himself to you, or an experience you've had with your students? So I wanted to give you all lots of notice that we're going to expect all of you to participate on March 26th and April 2nd. And April 2nd is just the day after Lee's birthday. So you can think about your testimony as a gift to Lee, right? So if you're like, oh, I don't like sharing, just think it's not sharing, it's giving Lee a gift. All right. And so that brings us to our final screen here. And so what questions can we answer for you this week? Or if you have something from lesson 25 you'd like to share, please feel free to share that too. You don't have to save it for April 2nd.
Kirsty, do you think it would be okay if I read the little snippet I sent you? It was like feedback from the mom. I think the little girl was 4. So the mom said her daughter wanted to take her math map book to church on Sunday morning. And she said, I couldn't find the right words to say, well, that's not one of our books about Jesus. But she said, but it is about Jesus. And well, it does point back to Jesus, but it's not the Bible. And she says, yeah, but it has scripture on it. And so she said, what is my life going to be like when she's 16?
Yeah, I loved that, Babs. That was such a sweet story.
I recently visited a community that I'm not particularly a part of, and I heard one of the directors that I know they're giving a testimony about the math map, and she had a few families that sort of dropped off a little bit at the beginning, whether they didn't understand it or couldn't see the vision. I'm not sure why, but the people who stayed and they were able to do this one-room schoolhouse thing with all their kids, she said that their minds were blown. They absolutely love it, and they have gotten so much out of it. And I think that that beauty and that passion is going to sort of like be contagious in the rest of the group and have people kind of go, okay, fresh legs again for challenge B, and let's see what we can do for this, because the testimony was just so beautiful and so encouraging. So I'm trying to get her to write it down so I can share it on one of those testimony pages. So we'll see how that goes. But it was a really good testimony.
Well, thanks for sharing that, Tanya.
Maybe I'll ask a quick question. Everybody around here, communities, know that I'm like crazy about the math map. So I've gotten several invitations to come like talk to moms about it. I have another one coming up next Saturday. And I'm just curious, like when somebody says, let's talk about the math map for 2 hours. Yeah, I just want to know what other people have done. I don't know how to translate all my exuberance in 2 hours. I have some ideas, but I just and I, obviously I have a lot of advice and whatever, but I'm just curious if there's does anybody have any feedback that comes to mind?
Well, I can give you some ideas, but I'm going to be quiet for a minute in case some other people have some things that they'd like to share.
Jana, I took that as my opportunity to become a book. So that way I also get paid when I talk about the math map. But I would maybe touch base with your book rep and see, because we do have events that we're doing now.
Yes.
And if you can tag team because it depends, like, and maybe you can probe a little and find out, like, okay, you want to talk about the math map for 2 hours. What does that mean? Does that mean you want to actually ask me questions, or do you want to voice your opinions? Like, what exactly are you looking for here?
Right. Well, I want to interact with it. And yes, thank you for the yes, our book rep lives very far away and has lots of people she's serving. So this is kind of an additional thing just to get our hands in it and do it together. I watched the little clip, Lee, that you sent in an email this week about whenever you're in any kind of situation, there's three things you should do. And one is educate yourself about it more, have a small group of people, and then serve. And I want to kind of talk about that a little, but I want to dig into it together as we talk about that. So, but that's helpful.
Yeah, Jana, I think that you've had so many great questions. I was thinking as we looked at these functions today, and then you had that question during the question time back in December about getting clearer on those types of things. And I don't know where what level the families are that you're going to be speaking with, but your question, which I didn't even understand your question when you asked back in December. But as I've been seeing this more and more, I see why you asked what you asked. And I understood the explanation and the answer of it, but there may be families there that don't even know what questions to ask because they just don't know the curriculum well enough. So, so I think I would be, if I were doing that, and I'm the same way around my area. Everybody knows I love the math map, and they come to me and ask me questions, and there's some frustration in our area as well. But I just keep saying, every time I talk about it, it's just, I see the beauty. I see the beauty in it. So just think back to some of the questions that you've asked and how you can help those families even understand the question to ask.
Jana, I think too, encouraging you to go over the layout of the booklet so that families can really understand. It's amazing to me that even on our orientation calls, as we're going through, reminding the leaders of what they heard last year about the book, about how really the words of ex nihilo is what we're repeating. But so many, they hear it, but they're not internalizing it. They're not realizing that the booklets themselves are such a great resource, that it's not a whole booklet of lesson pages, but there's actually the charts that help answer the questions. And there's the solutions key, and leaning into the solutions key, that's just those kinds of ideas of this classical Christian approach to math, and will help illuminate for them the understanding, because they have some of the grammar, but they still don't have enough grammar, as Kristen pointed out, to know what questions to ask. So if you start from, let's all have the same definitions, let's all look at how these page numbers of these booklets are unique, so that as you open the booklet, wherever you open it, and you look at a page number, that tells you where you are in the booklet and informs you of what it is that exactly what you're looking at. So.
Oh, I took a screenshot of your catechism questions too. I'm gonna read those because that's stuff, if you've looked at it for a while, it's automatic, you just know it. But so many people don't have that.
And we've
knowledge.
heard so many times how math is a language and understanding it as a language. One of the things I shared with a group one time, I brought in examples of other kinds of language. It could be a foreign language like Chinese or Russian or something, but also a softball scorecard or knitting directions or anything that had notations that unless you had learned how to read those notations, you didn't know what you were looking at. And usually someone in the room knew how to do one of those things. And they could say, oh, I recognize this. I know what this is. And we could say, this is what we want to equip our children with, is that they can say that about math. It doesn't mean you can knit everything that you can see directions for, but you know how to read it and you know where to start. And that's one of the things that if we don't teach our children the language of math, then it doesn't matter how much potential they have. We haven't given them the language to be able to communicate with it.
Yes, Jill, my favorite exordium when I did one of these I had just had a bunch of parents over that wanted to talk about Math Map. I happened to speak Spanish, so I said, most of you probably, let's count to 10 together in Spanish. So we all did that. And then I said, okay, so can everybody give me a number between 1 and 10 in Spanish of how excited you are about math? And they could all do that. And then I just started talking to them in Spanish and asking them like complex, more complex questions. And there was like 1 or 2 people that kind of understood a few words, but nobody could have a conversation with me. And I was like, okay, what just happened here? It was pretty powerful. So I like that I'm like, that's not necessarily, unless you speak a second language, that's not something you could use. But I like what you just said about like there's a language for everything. That's the classical model. There's a language for everything, and we learn the grammar first. We learn how to speak the language first before we can move on. And so good.
So I'm just going to contribute this, that I think, right, the reason why all of you show up every week and you're all so excited is because you're discovering God through mathematics, right? If all we were doing this week, during these calls, were math problems, and at the end of it, you could take the SAT, you'd all be like, okay, well, I don't really need the SAT, right? Or, well, I know enough to do that, or I already did that, right? If we're trying to sell the Math Map as just another math curriculum that is going to prepare your kids for the SAT or for college or the ASVAB or whatever it is that they decide to do, right? There's lots of options. The thing that really is the differentiator, I think, between the Math Map and other curricula, there are two big things. One, right, is we are looking at it from a truly Christian perspective, not how many levels of the, Tower of Babylon were built each day, if they built 3, but really saying our goal is to see the unseen. And to me, that is the thing that is going to change lives, right? And so if you can start by, if you have a lesson 29 booklet, Jana, that you filled, I would take that and I would say, can I just share with you how math has helped me get to know God better this year? Because that's what we all want, right? That's what we should want. We should be like Moses, who was like, all I want is more of God. And so if you can say to people like, look, the Math Map was invaluable to me because I learned this about God, I think the people are going to go, oh, well, I want to learn that about God, right? And no other math curriculum has that as its goal. And then the other piece of it, right, is really the community piece. And so you can take anything and make it classical. We do make that easier with the Math Map, right? We've laid it out in a way that makes it easier. But the Christian piece, that our whole purpose is seeing the unseen, right? Discovering God through math. And then the community piece, right? We're doing this together, right? We are not sitting in front of a computer and listening to somebody that doesn't know our student. We are doing this together, whether that's in our CC community or within our home, that the Math Map is designed to draw us into community together around mathematics. And so when I think we start from that, right, everybody wants to know God and everybody wants to belong. And if you can frame the Math Map within how that, like, just give your personal testimony, like, right, how can we do this? I think that that's where you're going to hook people. And then you can answer all the questions about, hey, this is how the booklets are set up. And hey, this is how you might work together with different age kids, or this is right. Then you can answer all those other questions. But the hook is going to be, I can know God and I can be in community with people and I can build relationships with people. So those are just my thoughts. And I can't imagine that anybody meeting with you, Jana, would not come away blessed from that time, regardless of what you say. So we are blessed that you were willing to speak on our behalf.
Yeah.
Well,
I don't know that this is really
everybody, oh, go ahead, Nina.
well, I'm not sure that this is like helpful particularly to Jana's event, but Robert was in Texas a few weeks ago speaking about educational independence. And I've heard him speak before. It's probably one of his best presentations ever seen him do. And I think the truth about all of this is that we have to be willing to do it for ourselves. And I think the math map, like I didn't take physics in high school because I was scared of it. And then through being a tutor and Challenge 4, like, and sitting down with my friends, and then doing the math map, even that fear has gone away. It might still be harder for me than someone else, or just difficult in general, but we have to be willing to sit down with the pen and paper ourselves, and maybe with our friends, and really do it for ourselves. Like no one can do it for us to the same degree. And just like you're saying, to like pursue, like to want more of God, nobody can do that for us. We have to really, and I just think there's just a little bit of a buy-in that there's a shortcut. I buy into it sometimes too.
We all do.
Yeah, I would like a shortcut. That'd be great.
I would say there is a shortcut. It's the classical model. Focus on the grammar and focus and over practice. And all of a sudden it will all just get easier. And the problem is we want to jump right to the dialectic without enough practice.
Yes, the dialectic without those blocks is mean. It's so mean. I remember when we started doing math more at home, one of my kids, it was actually my youngest, he really struggled when he got to a point that everybody else seemed to go through. And I went back and realized I had skipped a lot with him. We hadn't even talked about what numbers really are, because I figured, like you were talking about, Jana, with language, if you can count to 10, you can do this. So obviously now you can also do all of this. And so I went back to the very beginning with the Understanding Math book before I even knew there was a pilot here. And unlike me, I started at the beginning of the book, and we actually built a number line, and we actually talked about numbers. And it wasn't long till he was able to do all the things that were giving him a hard time, because I threw him into the dialectic pool with no swimming lessons.
Right. Well, we don't have to wait for some weeks for testimony, Kirsty. They're just so excited, and it's such a blessing. I need to go, and I want to just thank everybody for being here. Continue if Kirsty has time. I have to go on my way. Thanks, guys.
Thanks, Lee. Thanks for making this possible every week. It's a blessing.
Absolutely.
Well, are there any other questions that you guys would like to work through? If not, we will wrap up. But it is truly a blessing to meet with each one of you each week. And I love that this week we have some faces that we've missed for a little bit, and they're back. And so I want you to know that if you come and if you've been coming and you don't come, we miss you. So I don't necessarily call everybody out by name, but I do notice when people are gone, and I miss you. So it's always a blessing to see familiar faces back. So thank you.
Kirsty, I have a quick question. Do we know what the topics are going to be? Because it's coming to the end. It's kind of wrapping up. Do we know, are we taking a break after the April 2nd, or is it going to, or do we know, or is that a secret?
No, it's not a secret, because God knows. He may not have fully revealed that to us yet, but we know what we want to do for sort of the next iteration. But if, like last year, remember, we had sort of some weeks in between that were some different things. We've talked about having a couple of weeks where maybe we just play through the games on the back of the booklets, because I know that there's a lot of people who are kind of like, I don't know how to play this game. So we may place through some of those games on the back of the booklets together, just so that we can make sure we all know how to play those. So we've talked about maybe making that one of the things we do for a few weeks. Certainly, if any of you have like, hey, it would be great if we could have a book club focused on this topic, please let us know. We would be happy to do that. And then when we do start sort of the next round, sort of like next fall, which will probably start usually in July-ish, we will, where this year we take a look at the in-community outline, we're going to try and take a look at what would this look like at home. And so pulling in maybe monomials and fractions and integers, pulling those three together and saying, okay, well, if we were at home around the table, what are some ways that we could draw all of this into conversation, or what are some things that we could do specific to each of our students in those domains? So that's what we're looking at for next fall. But we are definitely open to your suggestions. If you have some suggestions for, you know, for sort of April, May, June that you would like to see, please let us know.
That sounds great. Thanks. Do we, oh, I forgot my question.
Well, if you remember it, or you guys are thinking, yeah, how do we let you know what our requests are? Don't forget, you can always email the mathmap@classicalconversations.com. Babs and Shauna are just amazing at getting those questions answered quickly. And if it's something that has a math bent to it, they'll share that with me and we will answer those too. So yeah, stay in touch.
Thanks so much.
Thank you.
Thank you.
Thank you.